All right, good morning, everybody. This is day 3.5, and once again, with some technical difficulties, we're filming it for the third time, so I'm going to try my best to just hit our most important ideas today. We are looking at something called the unit circle, so I don't know if you want to call it day 3.5. The unit circle is a circle with the center at the origin and a radius of 1. And by looking at the unit circle, it lets us investigate sine, cos, tan in relation to the coordinates of a point that's on the circle. All right, so I'm just going to draw a circle and put an xy axis behind it. If they told you this is the unit circle in the directions, then you can assume that this radius is 1, this is 1, 1, 1. It's 1 in every direction, obviously. So if you just have some random point, like xy, that is on the triangle, let's say it's here, we're still going to turn that, on the circle rather, sorry. We're still going to turn that into a triangle because of the way that we moved to get to this coordinate. So we went over x, and then we went up y, right? So this is my x move, this is my y move, and if I connect it to the center, that hypotenuse, of course, is going to be 1 because it's the unit circle, and if one of the radii is 1, then they're all 1. So this represents this coordinate, this generic point xy on the unit circle, and now we can look at sine and cos and tan in relation to this. So again, if we're talking about the angle in here by the origin, which we always are, sine of, let's just call it theta, would be the opposite side over the hypotenuse. It would be y over 1 or just y. The cos of theta would be the adjacent side over the hypotenuse, which would be x over 1, which is just the same as x. And then tan theta would be the opposite side over the adjacent side. So these formulas are something that you sort of need to memorize, or that you can memorize to make your life a lot easier. That in the unit circle, sine of the angle always corresponds with the y coordinate, cos with the x coordinate, tan is y over x. So you can just know that, or you would have to draw the picture and put all the sides on and figure it out. So let's do one example. Suppose they say negative 0.6 comma 0.8 is on the unit circle. Find sine theta. So here's what we can do. We can make a little sketch of that point, turn it into a triangle, find the missing side, yada, yada, yada. So we're just going to, even though it says it's on the unit circle, I'm not even making a circle at this point. I'm just plotting this point. So I'm going to go over and up. It's in this quadrant. And the coordinates will always be unusual like this. They will typically be decimals or fractions or something with a radical in them. Because remember, if you do Pythagorean theorem, I need the hypotenuse to always be 1 because of that idea of the unit circle. But suppose you didn't even know that and you're just going to pretend this is an x, then you would work that out like we've been doing right along, right? A squared plus b squared. You do negative 0.6 squared plus 0.8 squared equals x squared, which is 0.36 plus 0.64, which is 1 is x squared, so x is 1. It's like, oh yeah, unit circle, I guess I should have already known that was 1. But if not, you just work it out. And now let's do what we know to do. Sine is going to be the opposite side over the hypotenuse, so it's 0.8 over 1, which I know is a little awkward, but that's just 0.8. Cos theta is the adjacent side over the hypotenuse. And then tan theta is our opposite over adjacent. Now this, of course, can be reduced, But I just want you to recognize that if you hadn't done all this work and you saw that word unit circle, you would know right away that sine always corresponds with the y coordinate. Sine ended up being the y, cos is the x, tan is the y over x, and see how they're the y and the x, and it's just y over x. So if you've got these two right, it's kind of like you just draw a bar between them and it moves down for tan. The other way that I memorize this is sine is always the first one, and it does not go with the first one. So sine doesn't match up with the x, sine goes with the y. So your first trig word goes with the second coordinate, your second word goes with the first, and then tan, you just keep these in a row and put them over. In this example, they just asked for sine, but we just did them all to kind of show you. These are your choices. It's kind of an or. You can work it out and show it, or you can just memorize. If it's the unit circle, this is what happens every time. And again, if you're wondering where the circle is, it looks, like this or something. It's not great, but like that, right? They're just saying any point that's on the circle, and we would turn it into a triangle. All right, that's one big idea today. And now I want to talk briefly about those quadrantal angles. A quadrantal angle is an angle whose terminal side is on one of the axes. It's on the XY axis. So it's like a 90-degree angle. It doesn't actually fall in one of the quadrants. And if we look at the quadrantal angles in relation to the unit circle, I'm going to do all four of them so you can see one of each. So again, if we talk about the unit circle, it lets us kind of investigate coordinates and points and relationships. So if we're talking about a 90-degree angle, 90 degrees, of course, looks like this, right? One here and one here. This initial side is going to be 1, 0. So they might just tell you that to indicate the unit circle, or they might in the direction say, hey, it's a unit circle. So if this is 1, 0, and that means all radii are 1, you have to think about what this coordinate right up here would be on the terminal side. This coordinate would be 0, 1. So for 90 degrees, what's sine 90? Remember, sine always corresponds with the y coordinate, so sine 90 equals 1. Cos 90 equals 0, and tan 90 equals 1 over 0, and when you have 0 on the bottom, that means undefined. So what I'm saying is you can look at the quadrantal angles and the unit circle and know these values for sine, cos, tan of the quadrantals. Now, what we've been doing up until today was just putting them in. So in class, I told you can just do sine 90 and it tells you 1. I think on this new calculator, tan 90 actually says, oh yeah, it does. It actually says undefined. On the older calculator, it's going to say error, and you need to know, oh, if I get an error message, that means undefined value. All right, let's go ahead and do our other quadrantals. I'll show you 180 and 270 and then 360. So 180, of course, would look like this, right? Here, here. I don't know if you wanted me to put this like this for 90. Like this for 180. And then it's not about the initial start spot, it's about the terminating spot, which the terminal side is here, and that point would be -1, 0. So then this, actually, I'm going to go up here and just mark this up at the top as 90. That was our 91. Here's our 180. So again, sine of 180, sine corresponds with the y coordinate, sine of 180 is 0. Cos of 180 is always our x coordinate, which is -1. And tan of 180 degrees is 0 over -1. This one's not undefined because 0 divided by anything is 0, and those are your values. Now remember, you can type them in. So if you're stuck on these quadrantals, the good news is the calculator is a nice backup here. But I like this visual, and a lot of times I can remember this. So when students will go, what's cos 180 again? I can think of this and say, oh, cos 180, cos is the x. It's -1. I think it's -1, or something like that. Just because this visual sort of helps me to memorize that. All right, let's do 270 next. You know how this is going to go. I was kind of trying to color code them for you, but at this point you probably are like, move along. Here's 270 this way. And this coordinate would be 0, -1. So sine of 270 degrees is the y, cos is the x. Tan of 270, again, ends up undefined because of that 0 on the bottom. You can't write none or something like that. You need to label it as undefined if they ask you for tan 270. And then our last one, 360, which of course starts here, swirls all the way around and ends here, is this point right here at 1, 0. This is 360, we'll keep this one. So we've got sine of 360 degrees is 0, cos of 360 is 1, and tan 360 is 0 divided by 1, which is 0. I have 2 more examples for you today, I think, and then we are done. So the last thing I kind of have for you today is a combination of the chart and the thing that we just did. If they give you this f of x, which they often do give you an f of x type thing, plus cos 2x, and they ask you to find f of pi over 2, my first step would be to switch pi over 2 into degrees. Right now we're in radians because of the pi's. I need degrees to kind of know what's going on. So you might kind of want to go over on the side, pi over 2 times 180 over pi. We go straight across, we get 180 pi over 2 pi. The pi's drop out, 180 divided by 2, this is 90. So what we're really finding here is f of 90. I'm going to go down here just because I'm sort of out of space. So f of 90 degrees means 2 times sine 90 plus cos of 2 times 90. So this is 2 sine 90 plus cos 180. And then here, that sine 90, I'm going right back to the quadrantal angle that I had just drawn a minute ago. Oh, sine 90 is always 1, so I'm substituting a 1 there. Cos of 180 was -1. So I believe this is 2 minus 1. My answer here is 1. Whoops, I'm off the page, sorry. So this is how they might kind of combine the new stuff with the old stuff there. I thought I had one more for you. Yeah, I do. All right, one more of these and then we're done for today. All right, f of x equals sine of x over 2 plus tan x plus cos 3x. It's a little messy, sorry about that. And they want you to find f of pi over 3. Now you may be getting better at knowing what pi over 3 is right off. You can go on the side and kind of work that out and figure that out, just like we did up above. So if you want to go pi over 3 times 180 over pi, really what's going to happen right away with the pi's is that they're going to cross out. And pi is the same as 180 degrees, so it's just 180 divided by 3. This is 60 degrees. So the shortcut, instead of going straight across, and reducing, is knowing pi is always 180. So you just sub a 180 in there. 180 divided by 3 is 60. So we're going to really find f of 60, which means I'm going to put 60 into all of the spots where the x was. Plus tan 60 plus cos of 3 times 60. So it looks like sine 30 plus tan 60 plus cos 180. This 30 and 60, of course, come off that other chart that we have. The cos 180 is what we did today. Cos 180 is -1. Sine 30 and tan 60. So if you want to take a quick minute and jot the chart down just for practice, I would do that. You need to know it for your next quiz. I'm going to do it here, but if you want to pause the video for a quick minute and see if you know it, go ahead and pause. Okay, did you get it? All right, so now when I go back here, sine 30 is 1/2. Tan 60 is the rad 3. I can combine the two numbers, but not the radical, of course, so it looks like it's going to be rad 3 minus 1/2. Or you could write negative 1/2 plus rad 3. Either one is fine. And this will be my answer. So this is kind of stuff we had from last time. This 180 stuff is what we had from this time. All right, there was still one thing that I couldn't fit on the video because it's long enough, so thank you so much, and we'll just look at one more little thing related to the unit circle when I see you tomorrow in class. Have a great night, everybody.